Well, howdy there, Internet students. Mr. Hermanson again. We're going to do more using proportions to solve problems, many of them dealing with percents, and we're going to look at some problems where we are given the part and we need to find the whole today. So they look a little bit differently, and so you have to be able to identify when you're looking for the part, and I'll give you some hints as to how you do that. But let's get started here. Carrie's dad gave her some money to spend at the mall. Carrie spent 17 at the mall on a new pair of shoes. Carrie spent 85% of the money her dad gave her. How much money did Carrie's dad give her? So we're going to put the 85 over 100, but notice that we are wondering how much money Carrie's dad gave her. In other words, the total he gave her. So we're missing the whole. I'll put a W for whole. And the part that she spent is $17, so I'm going to put that there. Now when you solve this, you're going to do 17 times 100 and then divide that by 85. And so we get 20 is the total she was given to spend. Okay? So start to look for, think about, is this the part or is this the whole? Okay, so Steve and Anna went shopping during a sale at KC Wheels Bike Store. Anna looked at her receipt and saw that the total before the discount was $72, but she paid only $40. Steve's total before the discount was $38, but he only paid $18. Who saved a greater percent off the original price? All right, so what I like to do on a problem like this is figure out how much she's saving or he's saving and use that in your percent. So what I would do first is I would take the $72 that she's supposed to pay for the item and then subtract the $40 that she did pay for the item to find out how much she saved, because we want to know what percent that is off the original price. So I'm going to use the original price as my whole, and just so you know, and you can take this to the bank, you're always going to use the original as the whole. Okay, and then I'm going to use the savings, the money she saved, the discount, as the part. Okay, so I'll do Anna's here, and then you can do Steve's, and we'll see who's the better deal. So her part is 32 and the whole is 72. So we want to know what percent 32 is out of 72. So I'll put 100 there. And if you remember from the decimal stuff, we can actually just divide 32 by 72 when we get a problem like this and then move the decimal over 2 places. So she's saving about 44%. In other words, she's getting 44% off. Okay, so you figure out Steve. Make sure you figure out how much he's saving first by subtracting these two. Find out how much he's saving. And then put his original on the bottom, which is 38. And find out how much he's getting off, the discount he's getting in dollars, and put that on top. Okay, give that a shot. See how you do. And if you did that right, you'll see that he's saving 53% about. Okay, so we're going to say that Steve got a better deal on his bike. All right, you're making punch for the class party. The punch will contain juice and soda with at least 70% juice. You have 4 gallons of juice. What is the greatest amount of punch you could make? Okay, so it has to be at least 70% juice to taste good, basically. And we know that the juice is part of the mix. Okay, the rest of the mix is soda. So this 4 gallons is a part. So remember, we do part over whole equals percent over 100. Well, since the juice is only part of the mix, we're going to put that 4 gallons on top. And we're looking for the whole. And our percent is 70. Okay, so we're going to do 4 times 100 divided by 70 equals 5.7. We'll just round it to 5.7. So he can make 5.7 gallons. Notice again that our number that we had was the part. All right. Wayne spent 40% of his allowance on paper for a computer printer. If Wayne spent exactly $360, including tax on the paper, how much is allowance? So he's not spending all of his allowance. This is just part of it. So give it a shot. See if you can set it up. You should have got that his whole allowance was $9. All right. So the students at Mildridge Middle School could earn a special field trip day if they reach their book reading goal. They have read 6,500 books, which is 65% of the books needed. In other words, their goal. What is the book reading goal? Again, can you tell that this is part of the total? It's part of the goal. So use that as your part, set up your proportion, and see if you get the right answer. You should have got that the whole reading goal was 10,000 books. All right. So a gardener planted 13% of his tulip bulbs in the border of his garden and the rest in the garden bed. In spring, every one of the bulbs grew to a tulip. He counted 45 tulips in the border. How many bulbs had he planted altogether? Okay, again, this 45 is part of the total. It's only the ones on the border. So we're going to use that as your part. And then we're looking for the whole. Okay, so we're going to do 45 times 100 divided by 13. Equals, we're going to round that to the nearest whole number because we want a whole number of tulips here. So 346 tulips were planted. All right. The largest land animal, the African bush elephant, may weigh as much as 8 tons. However, this is only about 3.9% of the weight of the largest animal of all, the blue whale. How heavy can a blue whale be? So since the African elephant is smaller, it's only part of the weight. Again, part of the weight. So the 8 tons is the part again here. Okay, and you're going to find the whole. All right, you do the math, see if you got it right. If you did that right, you got about 205 tons. That's how much a blue whale weighs. Okay, according to the U.S. Census Bureau in 1950, the estimated world population was 2.6 billion. I like to underline my numbers. In 2007, it was 6.6. What percent of the 2007 population is the 1950 population? So we're looking for a percent here. And the whole, since it's out of the 2007, the whole is going to be the 2007 population, which is 6.6 billion. And in 1950, it was 2.6 billion. Now, when you're doing ratios and turning into percents, you can ignore all the zeros if you wanted to write out the big numbers in billions, and then just give your answer in billion. So on this problem, I would do 2.6 divided by 6.6. And so this is a percent, so we're going to multiply that by 100. And we get about, let's just round it to the nearest whole, 39%. So the population in 1950 is 39% of the population in 2007. Okay, so what percentage of the 1950 population is the 2000 population? So now it's out of the 1950 population. So in that one, we're going to use the 1950 as our whole and the 2007 as our part. Remember, these are in billions again. Doesn't matter because we're looking for the percent. So we're going to do 6.6 this time divided by 2.6. Multiply that by 100. And that is 250, was it 3%? 250, let's round it to 254. So the 2007 population, since it's bigger, is 254% of the 1950 population. Okay? In 2011, about 303 million people lived in the United States. What percentage of the world's population lived in the United States? Now, on this one, we're going to need to put in the zeros because now the United States is only part of the population, and it's 303 million, so we're going to need 6 zeros. And the whole population is 6.6 billion, so that would be a 6 like this. Okay, now if you want to get rid of some zeros, you can, as long as it's the same number on the numerator and the denominator. And we want to know what percent that is. So we're going to do 303 divided by 6,600. And multiply that by 100 to turn it into a percent. And we get about 4, I'm going to round it to 4.6%. All right. I'm going to let you try the last one, and then you can check back and see my work. Should have got 90,000 on that one. All right, so those are problems where you're dealing with finding the part. You could try your homework now, and we'll talk to you soon.